So implicit and explicit functions. So implicit and explicit, how to find them? So you're solving for y prime. We have a function like this. How do you solve for y prime when you have a function like this? So you want to solve for y prime, right? But you have y on this side, so you would have to factorize out after y by itself and then solve for y. But this is how you do it using derivatives. You look at the function. What kind of function is this? A product function, sum and difference function. So you use the formula. The derivative of dy of the function is 3x cubed minus x squared minus y plus y squared. So find the derivative of the entire thing. Right, so the derivative of 3x cubed is equal to 9x squared minus, now the derivative of this, let's say find the derivative of this now is a product. So if you use the product rule, you want to put this in brackets, so you just solve for this. So you can leave the negative sign outside. The derivative of a product is the first term times the derivative dx over dy of the second term, which is y. Anytime you find the derivative of y, when you multiply by dy dx, you find derivative of y, which is dy dx, not the same as dx dy, right? Only when you find derivatives. If you not find derivatives, you just leave it as y. So if you find the derivative of this, you find dy dx dy of it, and then you multiply by dy dx, right? Because that's what you want to find, y prime. This is y prime. So now it's first function by second function, derivative of second function, plus the derivative of the first function times the second function. So here you're not finding the derivative of second function, so just leave it as y. Only when you find the derivative of this, then you find. So here just leave it as y because you didn't find it. So that's how you use the product rule to solve this. Alright. So now this becomes so you could just write it as plus, if you want, continue. Derivative of 2y is 2, comes down, 2 minus 1 is 1, so you get 2y. Derivative of a constant is 0. So now you can just clear that up, so you get 2 squared. X squared derivative of y is 1, because 1 minus 1 is 0, so you get 1. Dy dx plus derivative of x squared is 2x, comes to line 1, by y plus 2y equals 0. So now you can clear that up a little bit again. You get x squared, 1 by 1 is 1, dy dx. So this is derivative of y. This is what you want to find. So you have dy dx plus 2xy. Oh, when you find the derivative of this, right? Derivative of y squared. So you have to find the derivative of y here as well, because you find the derivative of y squared. So you have to multiply by dy dx. This is going dy dx. So you get plus 2 2y dy over dx is equal to 0. So now 2y dy. Now you just distribute the negatives. So you get 9x squared minus x squared dy dx minus 2xy. So then you get plus 2y dy dx is equal to 0. So you want to solve for dy dx. So you bring dy dx by itself. So this is two variables by itself. So this can come on this side. So you get plus 2xy minus 9x squared right? Minus 9x squared. Okay, 9x squared. And then this stays on this side, so you get minus x squared. Right, so now, so now you get 2xy minus 9x. So you want to get dy by itself, so dy dx by itself. So now what's left is dy dx minus 2y dy dx. Right? So now that's left. So what you do now is you have to factorize this minus 2y dy dx, so minus 2y dy over dx is equal to 2. So now just factorize this out because you want to get dy by itself, so you get dy over dx, and you get negative x squared minus 2y is equal to 2xy minus 9x squared. So you get dy dx is equal to 2xy minus d squared all over minus x squared minus 2y. See that? So now you not only have you solve for y, but you find derivative at the same time. So the rules is like what? You find anytime you find the derivative of y, you just multiply by the dy dx, because that's what you want to find. You want to find the dy dx. You want to find derivative of y respect x. Here you find x derivative, so just do normal. Right, it's solved. Here you just find in dx dy, because you want to find the derivative of x. But when you have only when you find the derivative of y, then you find the derivative of dy dx. If you're just saying plus y, you just write back the plus y. You don't find the derivative of y every time. You just leave it as, and you'll get that. Factorize and you put dy dx by itself. This is what you want to find. Dy